divided by 2 because this green part here plus this green part would equal just A. And the rest in the middle should be equal to 1 minus A. That again could be easily calculated with standardization as we did before and using the tables. It was just says that the middle part consists of a certain percentage of outcomes that we have in our exercise or experiment. Now, let me clear that up. We are going to do an exercise. It's not such an exercise, just to explain you how the theory goes to the more practical side and doing the exercise. For example, we are given that alpha equals 0.5. And now we know that z of alpha divided by 2 is the z which is divided by 2, which is in our case 0.025. And how do we got that number here, 1.96? It's from the table. If we go to the last row of the table, I'm not sure I have it right now. I'm not sure if it's in that table also. No, it's not. The number that you would see, wait a second. No, I don't have the table in front of me, but if you see up front, you're gonna see 0.5, 0.05, 0.025, and so on. And if you see that column, and if you see the last row of that column, it should be 1.96. And the main idea behind our function, we are having z here, which is 0.025. That is what we have. Because in our case, alpha is divided by 2, but we are given alpha. And when we're given alpha, it means that that part here plus the same part on the left side, the sum of those two parts, it's alpha, because each one of them is just alpha divided by 2. And alpha is given, that is 0.05. And what does it mean? It means that 95% of our outcomes are in that period, in that interval, are here in the middle. This whole part is 95% of our outcomes. And for example, if we have the model N, again here a bracket, and we know that it's a good model and represents 95%, that is between the interval, which is 11.08 and 18.92. We can use the same standardization formula as before. We just get the first number, which is the mean, which is 15, minus the standard deviation. Not the standard deviation, but the number that we are given here. I'm sorry. Here we are given 8.96, and then we have that times the standard deviation. And the standard deviation is just the square root of the variance, which is here. And the variance is 4. It means that the standard deviation is square root of 4, which is just 2. Our y is just in between. And then we have the same thing, but with the plus. The mean plus the number, the quantile, times the standard deviation, that is 2. And if you get the numbers, you're gonna see the same interval that we are given. The main idea is to find numbers between which all outcomes, a certain percentage of the outcomes falls into. It's just orientation between how much likely are you going to have a number between that interval? How much likely you're going to be having the number? If you have another type of exercise, we're not given the mean, we have to find it. But it's also easy because we know the formula that constitutes of y minus the number plus y plus the number that we have. And we know that this interval, for sure, it includes the mean because the mean is always in the middle. So that interval here, it's always in it, it includes the mean. So if we can just substitute, we don't know the mean. So it's unknown, minus 1.96 because we remember it's z times the standard deviation, which is 2 because we have the variance of 4. And then we have the same part but with plus. And it's again 95% because 95% of the outcomes are within that interval. And in the end, we would have just y minus 3 times 92 if you calculate it. And the mean is between that interval. 25%, we are sure that the mean is between those two numbers. I'm going to clear that up and hope wasn't confusing for you and continue and see, okay, what the next chapters is about. I think you had this chapter this week, and it's about having joint probabilities, covariance, and correlation. The main difference between covariance and correlation, I'm going to explain now. So let's start with the covariance. The covariance is, let's imagine we have a sequence of some numbers. That's all outcomes that we have from the experiment, let's say. That's the sequence. And for example, we have here the mean. It's in the middle. But we know that not all outcomes are close to the mean. We have some distance between, for example, if we have an outcome here, it's too far away from the mean. But for example, that outcome here, it's not that far. So the covariance, it represents just the mean of all those deviations. It's like the distance between the mean and the number. And it's calculated between the covariance. It's denoted by cov, in brackets x comma y, and then we have the expectation of x multiplied by y minus the product of expectations of x and y. The correlation is about the strength of the linear relationship. So the covariance was just the linear relationship between x and y. But the correlation is how strong they are correlated. It can be a number that is above 1, and it can be a number that is below 1, minus 1. So it's always between that range. And if, for example, we know the correlations is exactly 0, it means that x and y are not correlated. They do not have any common relationship. If we know that the correlation is exactly 1, it means that x and y goes in the same direction at the same time. Their relationship is strong. There is a positive relationship, strongly positive. The same as if it's minus 1, it means that they are negatively related. And for example, if x go upwards, y would go downwards at the same time. But if you have a positive relationship, they go in the same direction at the same strength. And now we will have a quick exercise. So we are given, this exercise is about joint probabilities, and I took it from the lecture. So I'm not sure if you all have a look at the lecture still or you haven't watched it, but we're now going to explain it. That's the second part of that chapter. So we're having our table, and we have the connection between x and y. Let's imagine x is the stock price of share 1 and y the stock price of share 2. And the price of x could be equal to 29, either 30 or 31, but y is either 9, 10, or 11. So we have to determine the probability of having different events based on x and y. The first one is the total number between of x and y to be equal to 40. So we have to be careful. What does it mean to have 40 as a sum between x and y? It means that we can have, for example, x being equal to 30 and y being equal to 10. But we can have also x being equal to 31 and y being equal to 9. So there are a few options to think about it when it has to be exactly 40. If you have to determine the probability of having exactly 40 between those two shares, you have to calculate something different. If you have a look here, the probability of having x being equal to 29, for example, only not based on y, just x being 29. It has to be sum up of all those numbers, and it should be equal to 0.25, if I'm not wrong. If you calculate the probability of having x exactly 30, doesn't matter the y, it should be 0.45. If you calculate the probability of having 31 as x, not taking care of y, it should be 0.30. In the end, all that sum should be equal to 1. And why? Because all probabilities in the end should be equal to 1. And now, if you take a look again at the drawing, I'm going to delete those. We need to determine how much the probability would be for x plus y should be equal to 40. What do we have? First case, if x is 29, y should be 11, because those two have to be equal to 40. So that's our first case. Then if x is equal to 30, y has to be equal to 10, which is just 0.25. In the last option, if we have x equal to 31, then y should be equal to just 9. So that is the number that we're looking for. So we just have to sum up all those three to have the probability of having x and y equal to 40. And in the end should equal to 0.35 as an answer. The next one, we have to determine the probability of x. And now it comes useful to have those calculations handy, because the total probability of having x should be just having those separate probabilities of having each event. X equals 29, we have the probability 0.25. If x equals 30, we have 0.45. And we just calculate it. Just multiply the probability by the value of the event, which is 29 times 0.25. Then 30 times 0.45. And then 31 times 0.3. And that's the expectation. That's the mean. That's the average the stock one could go. That's the average value between those, which is 30.0.5. Was that clear? And do you need some more clarification? Okay. If we have to go for the third question, we have to determine the probability of having y, but we are given that x is equal to 31. So we are only interested in x equal to 31, which is that case here. But we know the total probability of having x equal to 31 is 0.3. So we just have to calculate 9, because we have to calculate 9 here. 9 times the probability of having that event divided by the total number, by the total probability, that is the whole x. 0.05 divided by 0.3 is just that event part of the whole sequence for x being equal to 31. And we just do the same as the numbers of y being equal to 10, then being equal to 11. And the conditional probability in the end should be equal to 10.33. If we're given the variance of x and the variance and y, and we have the covariance, And we know that we can invest 300 euros in stock 1, which is X, and 300 in stock 2, which is Y. And we have to determine the probability of having that portfolio. We have to determine the variance of that portfolio. I'm sorry, the variance. What would be the variance? Do you have an idea? If we know that U is denoted by our portfolio, U represents just our portfolio. We have 300 euros in stock X and 300 euros in stock Y. And the prices are given in the exercise. The first stock costs 30 euros and the second one 10 euros. It means that for the first stock, we are allowed to buy only 100 shares. For the second stock, that is Y, in which price is 10 per share, we are allowed to buy only 300. And that's our function. And we remember from the linear transformations that we take only the number that is attached to X or Y and put it to the power of 2. That's about linear transformations. We already had those formulas. We just take 100 in front, take it to the power of 2, and divide it by just the variance of X. But we are already given the variance of X, which is easy. 100 to the power of 2 times our variance of X. We do the same as Y. We have the variance of Y, take 300 to the power of 2, and take the variance, which is this number here. But the formula here, we should have to, it is exactly the same as the formula A plus B to the power of 2. That is A to the power of 2 plus 2 times AB plus B to the power of 2. We already have here A to the power of 2 and B to the power of 2. And now we have to take 2 times those two variants. So 2 times, we have 100 here, 100 times 300, 300 times, and the covariance, but the covariance, we are also given it in the table, in the exercise. So we just have to sum up the square of the first part, the square of the second part, and then 2 times this whole number. Do you find logic in those numbers and what it stands behind them? Do you have a question or an issue, or do you need to repeat something, or?
How did you come about 100 euros? 100.
Euros. Because here it says we have to invest 600 in total, but half of the money should go to stock X and half the money to stock Y. But we are already given the current prices of the stocks. So we know that the first stock price is 30 per share, but we have to invest 300 because that's the half. So 3,000 for stock X and 3,000 for stock Y. That's the total amount of money we can set aside for stock X. But we know the price per share is 30, so the number of shares we can buy is just 100 for X and then 300 for Y.
Okay, thanks.
You're welcome. Does anyone have another question? Okay, I'm gonna clear all that stuff and continue with a few more exercises that are generalized and from the whole material that we already took. That's the end of all chapters, and now we're gonna maybe focus on just exam strictly related exercises. So the first one is about, again, packs of coffee. I'm gonna give you, I'm not sure if 5 minutes would be enough, but just to go through A and B and see we can do it together. So I will give you 5 minutes to read and try to solve it, and then we're gonna make it together. Did you find a value for A? Not yet, okay. I'm gonna give you 2 more minutes to finish. If I can make you a hint, just make the graph and from just substitute a few numbers, see how the graph looks like, and then find, because A would be that number here. You have to find first how does the graph looks like, find all area below the graph that is equal to 1, and from then you can find A. Let's see. Yes, 1/25. That's right. So how did we go to the conclusion that A is 1/25? Firstly, make the graph again. I think the graph is the easiest way to visualize the numbers and see what type of figure we have. Firstly, if we just to know how the graph looks like, we have to plug in those numbers in the function and see if the graph is a rectangle or is it a rectangle, what it could be something weird, the graph, or like this. We have to plug in the numbers. So if we plug in the first number, 495, we would have 0A. So the graph in that point is here. If we have 496, it would be just 1A, should be somewhere here. Let's imagine this is A. And this is 496. If we have 497, the graph would be somewhere here, where is 2A. And the maximum point would be at 500. If we plug in 500 here, it would become 5 times A, which is exactly in the middle here. That is 5 times A. And it's increasingly step by step until it reaches 5 times A. The second side is the same as the first one, but here it is decreasing. Why? Because here we have 505 minus our x. If we substitute, we can see that, for example, if we substitute 502, it would become here 3 times x, 3 times A. In that way, we have a perfect triangle. So we know that the area below the triangle is just 1. We know that side here, which is just 10, times the height, which is 5 times A, but divided by 2 because that's a triangle, and that's equal to 1, which is just 50 times A divided by 2 equals 1, which is just A, 1/25, which is the answer in the chat, which is 0.04. If we have to have a look at B, determine the probability if x is precisely equal to 500. What would be your suggestion. First, I think about if x is discrete or continuous. It is not discrete, it's continuous. And I will explain now why. It says it's measured in grams, that's true, but it's not mentioned how many. Can we have 495 or can we have 495.5, 0.82, 0.62, whatever? We can have infinitely many grams here below. It's not mentioned that we have integers or rounded numbers. So the grams, we don't know, we're not able to count how many options we have here for outcomes. So it is continuous. So if it's continuous, we know that always, no matter whatever the number, when we have equal to some number and x is continuous, we would have that it's equal to 0. If it was discrete, we would have to look at the graph and make the area that corresponds to that number. And see the last point, if we have to calculate the probability that the deviation between x and the standard, that is 500 grams, is at most -2 or +2 grams. So the deviation is 2 grams. How can we calculate the probability? So it is between two numbers. The numbers are basically plus minus 2, and the standard is 500. So it should be 498, the minimum. Then we have x, and the maximum should be 502. That is the interval that we are interested in. We are allowed to have x only between those two numbers. We are not allowed to have 510 grams, for example. And here, we just remember we have a graph. We go to the graph and see how our numbers go there. We have 498, and here we have 502. And what we have to do right now, we just take the areas that correspond to each of those. And we need to find that area that is between those two numbers. It's an irregular form, so better find the rectangles that are here and take 1 minus those two small triangles. Do you want to try to do it on your own or just to go with a calculation and see how it goes? Okay. So firstly, we're gonna have a look at this triangle here. The area is 3 times the height, which is, we have to plug in that number in our function 498 in here. And it becomes 3 times a. But we already calculated a is 1/25. And divide it by 2 because that's a triangle. That's the area for this one here. The second triangle here, it's that side, which is also 3 times also the height, we take 502 and plug it in the second function, it will become just 3 times a. And a we already found is 1 over 25. And then we have divided by 2. And that's the area of those triangles. It's the same. And we have to take 1 minus those two combined. So it will become 3 times divided by 25. Because that's 1/2, so in the end is just 1. So 1 minus 9 over 25, it becomes 16 divided by 25. That's the probability that our packing of coffee would be between 498 grams and 502 grams. That's our probability of having such a pack. Is this exercise clear, understandable? I would say it would be pretty weird to understand everything completely on 100%. So we're not aiming at getting a 10 at the exam. At least I'm not aiming at 10, but at least to get the grasp of the main part. And it is fine if we don't understand maybe one concept on one formula. It's fine. We can still pass the exam if we don't understand some small parts of the whole material, because it's a lot. So if there are no questions, at least in the chat, I'm going to show you one exercise. That's the conclusion. Okay, we have an evaluation form between those two exercises. I was asked by Mac to send you that link here, because the participants should evaluate how the course went. If you have a minute, I would be more than happy if you could fill in. I think there are not many questions, but I'm not sure, so I'll give you 5-6 minutes to. Let me know when you're done with the form. Do you all fill it in or do you need more time? I'm done, okay. Done as well, okay. 2 out of 4. Should I assume that the other two people are done as well, or are you tired? Do you feel like continuing, or